Chemical reactions. Burning of magnesium in air. We will require a small piece of magnesium ribbon, sandpaper, tongs, china dish, red litmus paper and Bunsen burner. Take the magnesium ribbon and rub it with the sandpaper so it looks silvery white. Hold the magnesium ribbon with a pair of tongs. Light the magnesium ribbon. It burns brilliantly and a white ash is left behind. Collect the ash of the burnt ribbon in a china dish and label it as magnesium oxide. Magnesium burns in air to form magnesium oxide, MgO.
ಎಲ್ಲರಿಗೂ ನಮಸ್ತೆ. ಇವತ್ತು ನಾನು ಸಮೀಕರಣವನ್ನು ಹೇಗೆ ಸರಿದೂಗಿಸ್ಬೇಕು ಅನ್ನೋದನ್ನು ಒಂದು ವಿವರಣೆಯನ್ನು ಕೊಡ್ತಾ ಇದ್ದೇನೆ. ಇದಕ್ಕೆ ನಾನೀಗ ಒಂದು ಉದಾಹರಣೆಯನ್ನು ತೊಗೊಂಡಿದ್ದೇನೆ. ಕಬ್ಬಿಣವು ನೀರಿನೊಂದಿಗೆ ವರ್ತಿಸಿದಾಗ ಕಬ್ಬಿಣದ ಆಕ್ಸೈಡ್ ಮತ್ತು ಜಲಜನಕದ ಅನಿಲ ಬಿಡುಗಡೆ ಆಗುತ್ತದೆ. ಇದನ್ನು ನಾನು ಸಂಕೇತಾಕ್ಷರಗಳ ರೂಪದಲ್ಲಿ ಬರ್ಕೊಂಡಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ Fe+H2O gives rise to Fe3O4+H2. ಕಬ್ಬಿಣ ಮತ್ತು ನೀರು ರಾಸಾಯನಿಕವಾಗಿ ವರ್ತಿಸಿದಾಗ ಕಬ್ಬಿಣದ ಆಕ್ಸೈಡ್ ಮತ್ತು ಜಲಜನಕದ ಅನಿಲ ಬಿಡುಗಡೆ ಆಗುತ್ತದೆ ಎಂಬುದು ಇದರ ಅರ್ಥ. ಈಗ ಈ ಸಮೀಕರಣವನ್ನು ನಾವು ಸರಿದೂಗಿಸಬೇಕು. ಹೇಗೆ ಸರಿದೂಗಿಸೋದು? ಮೊದಲನೇ ಹಂತದಲ್ಲಿ ಈ ಒಂದು ಸಮೀಕರಣದಲ್ಲಿ ಯಾವ್ಯಾವ ಧಾತುಗಳು ಬಂದಿದೆ ಆ ಧಾತುಗಳನ್ನು ನಾವು ಪಟ್ಟಿ ಮಾಡ್ಕೋಬೇಕು. ಇಲ್ಲಿ ಯಾವ್ಯಾವ ಧಾತುಗಳಿದೆ? ಕಬ್ಬಿಣ ಇದೆ, ಜಲಜನಕ ಇದೆ, ಆಮ್ಲಜನಕ ಇದೆ. ಈ ಮೂರು ಧಾತುಗಳು ಈ ಸಮೀಕರಣದಲ್ಲಿ ಕಂಡು ಬರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ನಾನೇನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲಿ ಒಂದು ಧಾತುಗಳನ್ನು ಪಟ್ಟಿ ಮಾಡಿದ್ದೀನಿ. ಕಬ್ಬಿಣ Fe, ಜಲಜನಕ H ಮತ್ತು ಆಮ್ಲಜನಕ O. ಹಾಗಾದರೆ ಪ್ರತಿವರ್ತಕಗಳಲ್ಲಿ ಆ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ ಎಷ್ಟಿದೆ, ಆ ಧಾತುವಿನ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ, ಹಾಗೆ ಉತ್ಪನ್ನಗಳಲ್ಲಿ ಆ ಧಾತುವಿನ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ ಎಷ್ಟಿದೆ. ಉದಾಹರಣೆಗೆ LHS ಅಂದರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಪ್ರತಿವರ್ತಕಗಳಲ್ಲಿ ಕಬ್ಬಿಣ 1 ಪರಮಾಣು ಸಂಖ್ಯೆ ಇದೆ. ಹಾಗೆ RHS ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಂದರೆ ಪ್ರತಿ ಉತ್ಪನ್ನಗಳಲ್ಲಿ ಕಬ್ಬಿಣವು 3 ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ Fe3O4ನಲ್ಲಿ ಕಬ್ಬಿಣದ ಪರಮಾಣು ಸಂಖ್ಯೆ 3 ಇದೆ. ಅದೇ ರೀತಿ ಜಲಜನಕ ನೀರಿನಲ್ಲಿ ಜಲಜನಕದ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ 2 ಇದೆ. ಹಾಗೆ RHS ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಜಲಜನಕ 2 ಇದೆ. ಹಾಗೆ ಇಲ್ಲಿ ಆಮ್ಲಜನಕ ನೀರಿನಲ್ಲಿ 1 ಪರಮಾಣು ಸಂಖ್ಯೆ ಇದೆ. LHSನಲ್ಲಿ 1 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಅದೇ ರೀತಿ RHSನಲ್ಲಿ 4 ಇದೆ. Fe3O4ನಲ್ಲಿ ಅವು 4 ಆಮ್ಲಜನಕಗಳು ಇದೆ. ಸೊ ಹಾಗಾಗಿ ಅದನ್ನು ಏನು ಮಾಡಿದ್ದೀನಿ, ನಾನು 4 ಅಂತ ಹೇಳಿ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಇಷ್ಟನ್ನು ಬರ್ಕೊಂಡ ನಂತರ ಎರಡನೇ ಹಂತದಲ್ಲಿ ಏನು ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ಈ 3 ಧಾತುಗಳಲ್ಲಿ ಯಾವ ಧಾತು ಗರಿಷ್ಠ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆಯನ್ನು ಬಂದಿದೆ ಆ ಧಾತುವಿನಿಂದ ನಾವು ಸಮೀಕರಣವನ್ನು ಸರಿದೂಗಿಸ್ತಾ ಹೋದರೆ ಅದು ಹೆಚ್ಚು ಸೂಕ್ತ. ಸೊ ಹಾಗಾಗಿ ಈ 3ರಲ್ಲಿ ಯಾವುದಪ್ಪ ಹೆಚ್ಚು ಗರಿಷ್ಠ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆಯನ್ನು ಹೊಂದಿದೆ ಅಂದರೆ ಆಮ್ಲಜನಕ. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ನಾನು ಏನು ಮಾಡ್ತಾಯಿದ್ದೀನಿ, ಆಮ್ಲಜನಕದಿಂದ ಮೊದಲು ಆರಂಭ ಮಾಡ್ತಾಯಿದ್ದೀನಿ. ಹಾಗಾದರೆ ಈಗ ಆಮ್ಲಜನಕದ ಪರಮಾಣುಗಳು ಅಂದರೆ ಪ್ರಾರಂಭಿಕದಲ್ಲಿ ಎಷ್ಟಿದೆ ಅನ್ನೋದನ್ನು ನೋಡೋಣ. ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡು ಮತ್ತು ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಎಷ್ಟೆಷ್ಟಿದೆ. ಜಲಜನಕದಲ್ಲಿ ಆಮ್ಲಜನಕವು ನೀರಿನಲ್ಲಿ 1 ಪರಮಾಣು ಸಂಖ್ಯೆ ಇದೆ. ಹಾಗೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ Fe3O4ನಲ್ಲಿ ಆಮ್ಲಜನಕ 4 ಇದೆ. ಅದನ್ನು ಹಾಗೆ 4 ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಹಾಗಾದರೆ ಈಗ ನಾನು ಅದನ್ನು ಇಷ್ಟು ಸರಿದೂಗಿಸ್ಬೇಕು ಅಂದರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ 4 ಇರೋದ್ರಿಂದ ನಾನು ಪ್ರತಿವರ್ತಕಗಳಲ್ಲಿ ಕೂಡ 4 ಆಮ್ಲಜನಕದ ಪರಮಾಣುಗಳೇ ಇರಬೇಕು. ಅದು ಇರಬೇಕು ಅಂದರೆ ನಾನೇನು ಮಾಡಬೇಕು, ಈ 1ಅನ್ನು 4ರಿಂದ ಗುಣಿಸ್ಬೇಕು, ಪೂರ್ಣ ಸಂಖ್ಯೆಯಿಂದ ಗುಣಿಸ್ಬೇಕು. ಗುಣಿಸಿದಾಗ ನನಗೆ 4 ಬರುತ್ತೆ. ಆಗ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲೂ 4 ಆಮ್ಲಜನಕದ ಪರಮಾಣುಗಳಾಗ್ತವೆ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲೂ 4 ಆಮ್ಲಜನಕದ ಪರಮಾಣುಗಳು ಉಂಟಾಗ್ತವೆ. ಸೊ ಈಗ ನಾನು ಎಲ್ಲಿಗೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ 4 ಸೇರಿಸಬೇಕು? ಎಡಭಾಗದಲ್ಲಿ ನಾನು ಸರಿದೂಗಿಸಿರೋದ್ರಿಂದ ಪ್ರತಿವರ್ತಕಗಳಲ್ಲಿರ್ತಕ್ಕಂಥ ಆಮ್ಲಜನಕಕ್ಕೆ ನಾನೇನು ಮಾಡಬೇಕು? 4 ಸೇರಿಸಬೇಕು. ಈಗ ಈಕ್ವೇಷನ್ ಬರೆದ್ರೆ Fe ಪ್ಲಸ್ H2O ಇತ್ತಲ್ಲ ಇಲ್ಲಿ ಮೇಲೆ, ಅದಕ್ಕೆ ಏನು ಮಾಡಿದ್ದೀನಿ ನಾನೀಗ 4 ಸೇರಿಸಿದ್ದೀನಿ. ಅಂದರೆ ಆಮ್ಲಜನಕವನ್ನು ಸರಿದೂಗಿಸೋಕ್ಕೋಸ್ಕರ 4 ಹಾಕಿದ್ದೀನಿ. 4H2O gives rise to Fe3O4 ಪ್ಲಸ್ H2. ಅಂದರೆ ಇಲ್ಲಿ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ 4 ಆಮ್ಲಜನಕ ಆಯಿತು. ಈಗ ಇಲ್ಲೂ ಕೂಡ ಎಡಭಾಗದಲ್ಲೂ ಕೂಡ 4 ಆಮ್ಲಜನಕನೇ ಆಗಿದೆ. ಈಗ ಆಮ್ಲಜನಕ ಸರಿದೂಗ್ತು. ಇಲ್ಲೂ 4 ಆಯಿತು, ಇಲ್ಲೂ 4 ಆಯಿತು. ಈಗ 3ನೇ ಹಂತಕ್ಕೆ ಬರೋಣ. ಯಾವ್ಯಾವುದಿನ್ನೂ ಸರಿದೂಗಿಸಲ್ಪಟ್ಟಿಲ್ಲ? ಆಮ್ಲಜನಕ ಏನೋ ಆಯಿತು. ಈಗ ಕಬ್ಬಿಣ ಮತ್ತು ಜಲಜನಕ ಎರಡೂ ಕೂಡ ಸರಿದೂಗಿಲ್ಲ ಸಮೀಕರಣ. ಸೊ ಈಗ ನಾನೇನು ಮಾಡ್ತೀನಿ? ಜಲಜನಕವನ್ನು ತಗೊಳ್ತೀನಿ. ಈ ಜಲಜನಕದಲ್ಲಿ ಪ್ರಾರಂಭಿಕ ಹಂತದಲ್ಲಿ ಎಡಭಾಗದಲ್ಲಿ ಎಷ್ಟಿದೆ, ಬಲಭಾಗದಲ್ಲಿ ಎಷ್ಟಿದೆ? ಅಂದರೆ 4H2Oನಲ್ಲಿ ಎಷ್ಟು ಜಲಜನಕದ ಪರಮಾಣುಗಳಿದೆ? 4 8 ಜಲಜನಕದ ಪರಮಾಣುಗಳಿದೆ. ಹಾಗೆ RHSನಲ್ಲಿ ಎಷ್ಟು ಜಲಜನಕದ ಪರಮಾಣುಗಳಿದೆ ಅಂತ ನೋಡಿದರೆ 2 ಇದೆ. ಜಲಜನಕದಲ್ಲಿ 2 ಇದೆ. ಸೊ ಅದನ್ನು ನಾನೀಗ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ಇದಾದ ನಂತರ ಸರಿದೂಗಿಸ್ಬೇಕು. ಎಷ್ಟಕ್ಕೆ ಸರಿದೂಗಿಸ್ಬೇಕು? ಎಡಭಾಗದಲ್ಲಿ 8 ಜಲಜನಕದ ಪರಮಾಣುಗಳಿರೋದ್ರಿಂದ ಬಲಭಾಗದಲ್ಲೂ ಕೂಡ 8 ಜಲಜನಕದ ಪರಮಾಣುಗಳೇ ಇರಬೇಕು ಅಂದರೆ ನನ್ನ ಹತ್ರ ಇಲ್ಲಿರೋದೇ 2. ಸೊ ಈ 2ಕ್ಕೆ ನಾನೇನು ಮಾಡ್ತೀನಿ? ಪೂರ್ಣ ಸಂಖ್ಯೆ 4ರಿಂದ ಗುಣಿಸ್ತೀನಿ. 2 4 8. ಎಲ್ಲಿ? ಈಗ ಈ 4 ನಾನು ಎಲ್ಲಿಗೆ ಸೇರಿಸಬೇಕು? ಸಮೀಕರಣದ ಬಲಭಾಗದಲ್ಲಿರುವಂತಹ ಜಲಜನಕಕ್ಕೆ ನಾನು 4 ಸೇರಿಸಬೇಕು. ಗಮನ ಇರಲಿ. ಸೊ ಈಗ ನೋಡಿ, ಮತ್ತೊಮ್ಮೆ ಸಮೀಕರಣವನ್ನು ಬರ್ಕೋಬೇಕು. Fe ಪ್ಲಸ್ 4H2O gives rise to Fe3O4 ಪ್ಲಸ್, ಈಗ ನಾನು ಇಲ್ಲಿರುವಂಥ ಜಲಜನಕಕ್ಕೆ 4 ಸೇರಿಸಿದ್ದೀನಿ. 4H2 ಅಂದರೆ 4 8 ಜಲಜನಕ ಆಯಿತು ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ. ಹಾಗೆ ಇಲ್ಲೂ ಕೂಡ 4 8 ಜಲಜನಕ ಇದೆ. ಸೊ ಈಗ ಜಲಜನಕ ಸರಿದೂಗಿದೆ, ಆಯಿತು. ಇಲ್ಲೂ 8 ಆಯಿತು, ಇಲ್ಲೂ 8 ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಈಗ 4ನೇ ಹಂತದಲ್ಲಿ ಕಬ್ಬಿಣ ಒಂದೊಂದು ಸರಿದೂಗಿಸಿಲ್ಲ. ಸೊ ಅದನ್ನು ಸರಿದೂಗಿಸ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಕಬ್ಬಿಣ ತೆಗೆದುಕೊಂಡಿದ್ದೀನಿ. ಪ್ರಾರಂಭಿಕದಲ್ಲಿ ಕಬ್ಬಿಣ ಎಷ್ಟಿದೆ ಅಂದರೆ ಇಲ್ಲಿ ನೋಡಿ, ಪ್ರಾರಂಭಿಕದಲ್ಲಿ ಎಡಭಾಗದಲ್ಲಿ ಪ್ರತಿವರ್ತಕದಲ್ಲಿ ಕಬ್ಬಿಣ 1 ಇದೆ. ಹಾಗೆ ಬಲಭಾಗದಲ್ಲಿ ಎಷ್ಟಿದೆ? 3 ಇದೆ. Fe3O4ನಲ್ಲಿ 3 ಕಬ್ಬಿಣದ ಪ್ರಮಾಣ ಸಂಖ್ಯೆಗಳು ಕಂಡು ಬರ್ತಾ ಇದೆ. ಅದನ್ನೇ ನಾನೀಗ ಇಲ್ಲಿ ಬರೆದಿಟ್ಕೊಂಡಿದ್ದೀನಿ. ಹಾಗಾದರೆ ಸರಿದೂಗಿಸ್ಬೇಕು. ಇಷ್ಟಕ್ಕೆ ಇಲ್ಲಿ ಬಲಭಾಗದಲ್ಲಿ 3 ಕಬ್ಬಿಣದ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ ಇರೋದ್ರಿಂದ ಎಡಭಾಗದಲ್ಲಿರುವಂಥ ಕಬ್ಬಿಣವನ್ನು ನಾನು 3 ಸಂಖ್ಯೆಯಿಂದ ಗುಣಿಸಿದ್ರೆ ಅದೆರಡೂ ಕೂಡ ಸಮ ಆಗುತ್ತೆ, ಸರಿದೂಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ನಾನು ಎಡಭಾಗದಲ್ಲಿರ್ತಕ್ಕಂಥ ಕಬ್ಬಿಣಕ್ಕೆ 3 ಸಂಖ್ಯೆಯಿಂದ ಗುಣಿಸ್ತಾ ಇದ್ದೀನಿ. 3Fe ಪ್ಲಸ್ 4H2O gives rise to Fe3O4 ಪ್ಲಸ್ 4H2. ಅಂದರೆ ಈಗ ನೋಡಿ, ಇಲ್ಲೂ 3 ಕಬ್ಬಿಣ ಇದೆ ಎಡಭಾಗದಲ್ಲಿ, ಇಲ್ಲೂ ಕೂಡ 3 ಕಬ್ಬಿಣದ ಪರಮಾಣುಗಳ ಸಂಖ್ಯೆ ಇದೆ. ಹಾಗಾದರೆ ಈ ಸಮೀಕರಣ ಈಗ ಸರಿದೂಗಿದೆ ಅಂತ ಹೇಳಿ ಅರ್ಥ.
Combination reaction. We'll require quicklime, distilled water, beakers, spatula, glass rod, test tube, dropper and lime water. Take a small quantity of lime water using a spatula and transfer it into a beaker. Thermometer, glass rod. Slowly add water into the beaker so that quicklime remains submerged in the water. quicklime reacts vigorously with water to produce a suspension of slaked lime, releasing a large amount of heat. Leave the beaker undisturbed for some time. A clear solution of lime water appears as the suspension of slaked lime settles down. Take a small quantity of lime water using a dropper and transfer it into a test tube. Then cork the test tube with a cork and insert a glass tube through the hole in the cork into the test tube. Blow exhaled air into the test tube through the glass tube. On blowing exhaled air, which contains sufficient CO2 gas, it turns the lime water milky. In this reaction, quicklime and water combine to form a single product, slaked lime, calcium hydroxide, so it is a combination reaction. Decomposition reaction. Take a small quantity of ferrous sulfate crystals, FeSO4, 7H2O in a dry boiling tube. Hold the boiling tube with a test tube holder. Heat the boiling tube over the flame of a burner. On heating, ferrous sulfate crystals lose its water molecules and form white-colored crystals of anhydrous ferrous sulfate, FeSO4. On further heating, anhydrous ferrous sulfate decomposes to form dark brown-colored ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3 gases. The gas emitted has the odor of burning sulfur. In this reaction, a single reactant FeSO4 decomposes to form three different products, Fe2O3, SO2 and SO3. So the reaction is a decomposition reaction. Decomposition reaction. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. The substance or substances initially involved in a chemical reaction is called a reactant or a reagent, and the newly evolved chemical substance is called the product. There are many types of chemical reactions. Chemists have classified them as combination reaction, decomposition reaction, displacement reaction, and double displacement reaction, depending on the chemical changes that take place in the reaction. In a combination reaction, two or more substances combine to form a new compound, whereas in a decomposition reaction, a single compound undergoes a reaction that produces two or more simpler substances. In a displacement reaction, one element replaces a similar element in the compound, whereas in a double displacement reaction, the ions of two compounds exchange places in an aqueous solution to form two new compounds. The aim of this experiment is to find the action of heat on ferrous sulfate crystals and classify it as a combination reaction, decomposition reaction, displacement reaction, or double displacement reaction. Materials required: hydrated ferrous sulfate crystals, Bunsen burner, boiling tubes, test tube holder and spatula. Procedure: take a small quantity of hydrated ferrous sulfate crystals and transfer it into a dry boiling tube using a spatula. Hold the boiling test tube with a test tube holder and note the color of the hydrated ferrous sulfate crystals, which may be light green in color. Heat the boiling tube over the flame of a Bunsen burner. On heating, the color of the crystals change from light green to white. This is due to the formation of anhydrous ferrous sulfate that is produced on heating hydrated ferrous sulfate crystals. Anhydrous ferrous sulfate is formed due to the loss of water molecules on heating hydrated ferrous sulfate crystals. On further heating, the white substance changes to a dark brown solid. While heating, smell the fumes coming out of the boiling tube and note the odor. Here, anhydrous ferrous sulfate decomposes to form a dark brown solid, that is ferric oxide, sulfur dioxide and sulfur trioxide, which are emitted out of the boiling tube as gases. Finally, transfer the dark brown substance in the boiling tube into a watch glass and label it as ferric oxide. From the observation, it becomes clear that this is a decomposition reaction, as a single reactant, anhydrous ferrous sulfate, breaks down to give simpler products like ferric oxide, sulfur dioxide and sulfur trioxide. Precautions: always use a test tube holder while heating the test tube. Avoid inhalation of sulfur dioxide and sulfur trioxide as they may cause difficulty in breathing.
Electrolysis of water. If electricity is used for decomposing a substance, it is called electrolysis. When electricity is passed through acidic water, it decomposes into oxygen and hydrogen gases. But water is a bad conductor of electricity. Therefore, a little salt or a little alkali is added to water for easy conduction of electricity. Dissolve a little quantity of acid in water. Pour the solution in an apparatus as shown here. Fill 2 test tubes with solution and see that no air bubbles are present. Invert these test tubes over the iron nails. These are called electrodes. Connect these outer electrodes to the positive and negative terminals of a battery. You can see that gases are produced in the 2 test tubes. After 30 minutes, examine the volume of each gas formed in the test tubes. Are the volumes of gases equal? Introduce a glowing splinter into the test tube in which less amount of gas is formed. The splinter burns brilliantly. Therefore, we can say this gas is oxygen. Introduce another glowing splinter into the test tube in which more volume of gas is formed and observe it. This splinter is put out with a pop sound. But the gas burns with blue flame. Hydrogen possesses this property. Therefore, we can say that the gas present in this test tube is hydrogen. In this way, sending electricity through water and decomposing into oxygen and hydrogen is called electrolysis.
Single displacement reaction. We will require copper sulfate, iron nails, distilled water, a beaker, measuring jar, test tubes, 2 clamp stands, a piece of thread and a glass rod. Take sufficient quantity of distilled water in a measuring jar and pour it into a clean beaker. To this, add a required quantity of copper sulfate. Stir the contents in the beaker using a glass rod until the copper sulfate crystals in the beaker dissolves completely. Pour sufficient quantity of copper sulfate into a test tube. Clamp the test tube to a stand. Then pour sufficient quantity of copper sulfate into another test tube. Clamp this test tube to another stand. Take 2 iron nails. Clean these by rubbing them with sandpaper so their color appears grayish. Tie 1 nail with a thread. Immerse this into one of the test tubes containing copper sulfate solution. Keep the 2 test tubes undisturbed for about 15 minutes. After 15 minutes, the color of the copper sulfate solution containing the iron nail turns light greenish color, whereas the color of the solution in the other test tube does not change. The greenish color of the solution is due to the presence of Fe2+ ions. Remove the iron nail from the solution. Compare it with the other nail. There is a brown coating of copper on the nail that was dipped in the copper sulfate solution. The other nail retains its grayish color. In this reaction, the ferrous ions displace copper ions from the copper sulfate solution. So the reaction is a single displacement reaction. Displacement reaction. Displacement reactions are those chemical reactions in which one chemical species of a reactant is replaced by another chemical species. Displacement reaction can be generally classified into 2: single displacement reaction and double displacement reaction. Single displacement reaction. Single displacement reaction may be defined as the chemical reaction in which a more reactive element displaces a less reactive element from the soluble solution of its compound. Further, the displacement reactions are very common in metals. Let's consider a reaction between copper metal and silver nitrate solution. Here, copper displaces silver from aqueous solution of silver nitrate. Now, non-metals also take part in displacement reaction. When chlorine gas is passed through aqueous solution of potassium bromide, chlorine will displace bromine from potassium bromide solution. And in case of metals which are more reactive than hydrogen, displace hydrogen from dilute acids. When zinc metal is placed in dilute sulfuric acid, zinc metal displaces hydrogen ions H+ as hydrogen gas. Similarly, highly reactive metals replace hydrogen from water. As such, calcium in water reacts and forms calcium hydroxide and hydrogen gas. Double displacement reaction. Double displacement reactions may be defined as the chemical reactions in which one component, each of both the reacting molecules, get exchanged to form the products. Double displacement reactions can be further classified into three types: neutralization reaction, precipitation reaction, and gas formation reaction. Let's now learn about these reactions. Neutralization reaction. In the neutralization reaction, an acid and base react to form salt, which is neutral in nature, and water. On mixing aqueous solution of hydrochloric acid with aqueous solution of sodium hydroxide, sodium chloride and water is obtained. HCl plus NaOH gives NaCl plus H2O. Precipitation reaction. Precipitation reaction occurs when aqueous solutions of two ionic compounds are mixed and the ions combine to make a compound that is not soluble in water and is called the precipitate. On passing hydrogen sulfide gas through aqueous solution of copper sulfate, a black precipitate of copper sulfide is formed. Gas formation reaction. A double displacement reaction where an insoluble gas is formed. Such a reaction is called gas formation reaction. When dilute hydrochloric acid is added to aqueous solution of sodium carbonate, carbon dioxide gas is formed. Things to remember. In displacement reactions, chemical species of a reactant is replaced by another chemical species. Single displacement reaction is a chemical reaction where more reactive element displaces a less reactive element. In double displacement reaction, one component each of both the reacting molecules get exchanged to form the products. In neutralization reaction, an acid and base react to form salt and water. Precipitation reaction occurs when aqueous solutions of two ionic compounds are mixed to form a compound which is not soluble in water. A double displacement reaction where an insoluble gas is formed is called gas formation reaction. Double displacement reaction. Chemical reactions are part of our daily life, from photosynthesis occurring in plants to cooking of food in the kitchen. There are different sets of chemical reactions happening around us. A chemical reaction happens when two or more elements interact together to form a chemical bond between atoms and form a chemical compound. Chemists have classified the chemical reactions into 4 different types depending upon the type of chemical change occurring in a reaction. Combination or synthesis reactions are those in which 2 or more chemical elements or compounds unite to form a more complex product. Decomposition reactions are those in which a compound is decomposed into smaller compounds or elements. Single displacement reactions are characterized by an element being displaced by a more reactive element. double displacement reactions represent those reactions in which two compounds exchange ions or bonds to form different compounds. The aim of this experiment is to study the reaction between sodium sulfate and barium chloride solutions and classify it as a combination reaction, decomposition reaction, displacement reaction, or double displacement reaction. Materials required: boiling tubes, solution of sodium sulfate and solution of barium chloride. Procedure: take a small quantity of sodium sulfate solution in a boiling tube. Then, take a small quantity of barium chloride solution in another boiling tube. Pour the barium chloride solution taken in the boiling tube into the boiling tube containing sodium sulfate solution. On adding, a white precipitate of barium sulfate is formed in the boiling tube. This confirms the presence of sulfate ions in the solution. Now keep the contents of the boiling tube undisturbed for 10 minutes. After 10 minutes, we can see that the white precipitate in the test tube settles to the bottom of the test tube. Now, decant the upper solution in the boiling tube into the beaker. Add a few drops of dilute HCl to the white precipitate of barium sulfate and shake the test tube well. You can observe that white precipitate remains insoluble in the dilute HCl. Here, a chemical reaction occurs between sodium sulfate and barium chloride to form barium sulfate and sodium chloride. This is a double displacement reaction in which sulfate ions are displaced by chloride ions and chloride ions are displaced by sulfate ions.
Oxidation and reduction, redox reaction. Aim: formation of copper oxide from copper. Requirement: china dish, copper powder, burner, tripod stand and wire gauze. Activity: heat a china dish containing some amount of copper powder and observe what will happen. We can observe the surface of copper powder becoming coated with black copper oxide. Because oxygen is added from air to copper and copper oxide is formed, 2Cu plus O2 gives rise to 2CO. If hydrogen gas is passed over this heated material, copper oxide, CuO, the black coating on the surface turns brown due to reverse reaction and copper is obtained. CuO plus H2 gives rise to Cu plus H2O. If substance gains oxygen during a reaction, it is called oxidized. If substance loses oxygen during a reaction, it is called reduced. In this reaction, copper 2 oxide is losing oxygen and is being reduced. The hydrogen is gaining oxygen and is being oxidized. One reactant gets oxidized while the other gets reduced during reaction is called redox reaction.
Classify the type of reaction. Materials required for this activity: white crystalline lead nitrate, Bunsen burner, dry test tube with holder, incense stick, and one spatula. Now let's do the activity. Take about 2 grams of the white crystals of lead nitrate in a dry test tube. Heat it over the flame, and care must be taken here. Tilt the test tube away from you to avoid fumes. Observe the heating process carefully. You can see that lead nitrate is producing a crackling sound along with brown fumes of nitrogen dioxide. Let's burn the incense stick, and let's put glowing stick inside the test tube, and you will see that it reignite. And we see the observations here. First observation is color change. There is a color change. White color lead nitrate is heated and it get converted into yellow colored lead oxide. Second observation is brown fumes evolved here, and these brown fumes are due to nitrogen dioxide gas. Third observation, the glowing stick reignite, which suggests the presence of oxygen in the reaction. Chemical reaction involved here: lead nitrate after heating converted into simpler compounds that are lead oxide, which is yellow in color, nitrogen dioxide having brown fumes, and oxygen gas. So we can classify it as a thermal decomposition reaction. The decomposition reactions are those reactions in which a single compound splits into 2 or more simpler compounds under suitable conditions. Thanks for watching.